Good evening, participants. A warm welcome to you all to the 15th session of Power Talks on Renewable Energy by Ms. Khadeeja Beevi, MA of Adi Shankara Institute of Engineering and Technology. On behalf of IEEE PES Kerala chapter, I welcome Khadeeja to present her talk on renewable energy. Khadeeja, over to you.
Okay, thank you. Thank you for the introduction. Good evening, everyone. Hope you all are doing well. Myself, Khadeeja Beevi, second year student at Shankara Institute of Engineering and Technology. Today, I'm here to take a small session on the topic renewable energy. Okay, now let's get started. First of all, energy. This is the word that we all are familiar with. This word energy since our upper primary classes, right? And energy is nothing but it is defined as the ability or capacity to do work. And energy lights our cities, power our vehicles, and runs machinery in factories. There are so many types of energy like chemical energy, thermal energy, electrical energy, mechanical energy, and so on. And energy warms and cools our homes. That is under thermal energy, and cooks our that is heat energy, and plays our music and give us pictures on television. That is electrical energy. And now let's look what are the types of energy. The mainly energy is classified into two: renewable energy and non-renewable energy. Renewable energy means it is the energy obtained from the sources that are essentially inexhaustible, such as sun and wind, etc. And non-renewable energy means it is the energy that comes from the ground and it is not replaced in a relatively short amount of time. Day by day, our energy requirement and power requirement is increasing. To fulfill that requirement, we need to have some additional sources, right? So, and those sources should not be exhaustible, and otherwise, what will happen? One day we will have to buy energy at any cost. So, now let's move on to non-renewable energy examples. These are the examples of non-renewable energy: thermal power plants using fossil fuels such as coal, petroleum oil, or natural gas. And nuclear energy is also an example of non-renewable energy. Uh, then, okay, now we will come down to the actual part of our session: renewable energy. What do you actually mean by renewable energy? What does the word renewable energy actually means? The word renewable energy means nothing but a source of energy that is uh, that is not depleted by use such as solar power and wind and water. Mm, a renewable energy system converts the energy from the sunlight, wind, falling water, that is hydro, and sea waste. Then geothermal heat. Geothermal heat means that or biomass into a form of heat or electricity. Then geothermal means there is a temperature in earth. That temperature can be converted water into heat and then into steam. When we convert into steam, that steam can be used to rotate the turbine, and the rotation of turbine, that is mechanical energy, that will be given to the generator, and it will give some output that is nothing but the power or energy, and that is called a geothermal energy. And in the next one, biomass. Nowadays, so many people are aware about this, and it is nothing but we are converting the gas from the waste, same agricultural waste, and that is used for the generation of energy. So these are the different ways like sunlight, wind, hydro, sea waste, geothermal heat, and biomass. We are actually trying to convert these into heat or into electricity. Now, what are the different types of renewable energy? We all are very familiar with this: solar energy, wind energy, hydropower, biomass, geothermal, tidal energy, wave energy, and ocean thermal energy conversion. Solar energy, all of us are very well known about this. Nowadays, everybody is trying to use solar power in the form of light or heater, etc. And wind energy. Wind energy or wind power describes the process by which wind is used to generate electricity. And next one, hydropower. And hydropower water is normally stored in dams. That stored water have some kinetic energy when it flows through a penstock pipe, and that kinetic energy is used for the energy generation. And the next one is geothermal energy. Geothermal energy that we have already discussed earlier, and biomass also, and tidal energy. In tidal energy, we are trying to use the waves which are coming in and going out. And ocean thermal energy conversion, that is also called OTEC. And ocean thermal energy conversion in this type, what people are trying to do that there are a difference between the temperature. When there is a difference between the temperature, that temperature difference can be used for energy generation. And next one, we will discuss the detail all about this. First one, solar energy. Solar power can be harnessed and converted to usable using photovoltaics or solar thermal collectors. Although solar energy only account for a small amount of overall global energy use, the falling cost of installing solar panels means that more and more people in more places can take advantage of solar energy. Solar is a clean, renewable energy resource and figures to play an important part in the global energy future. Then there are many ways to use energy from the sun. The main two ways to use energy from the sun are photovoltaics and solar thermal capture. For photovoltaics are much more common for smaller scale electricity projects like residential solar panel installation, and solar thermal capture is typically only used for electricity production or massive scales in utilities solar installation. And the next one is wind energy. In wind energy, wind is used to produce electricity using the kinetic energy created by the air in motion. That is transformed into electrical energy using wind turbines. Wind first hits the turbines blades, forcing them to rotate and turn the turbine connected to them. That changes the kinetic energy to rotational energy by moving a shaft which is connected to a generator and thereby producing electrical energy through the electromagnetism. And the next one is hydropower. In hydropower, the dams stores a lot of water behind it in the reservoir. Near the bottom of the dam wall, there is the water intake, and gravity causes it to fall through the penstock inside the dam. And at the end of the penstock, there is a turbine goes into the generator which produces the power. And the power lines are connected to the generator that carries the electricity to our homes. And the next one is geothermal energy. Geothermal energy, this heat is called geothermal energy, and people can capture geothermal energy through geothermal power plants, which use heat from deep inside the earth to generate steam to make electricity. Uh, and resources of geothermal energy ranges from the shallow ground to hot water and hot rocks. Depending on the characteristics of geothermal, it can be used for heating and cooling purposes or be harnessed to generate clean energy, clean electricity. And the next one, tidal energy. Tidal energy is a form of hydropower that works by harnessing the kinetic energy created from the rise and fall of ocean tides and currents, also called tidal flows, and turns it into usable electricity. And the larger the tidal range or the height difference between the sea level at high and low tide, the more power can be produced. And the next one is thermal energy. And the ocean cover 75% of the world surface, so which generates power from the temperature difference between warm surface seawater and cold seawater at 800 to 1000 meters depth. And it is the largest renewable energy source available to contribute to the security of the energy supply and reduce greenhouse gases emissions. And next one is uh, biomass. Biomass energy is energy generated or produced by living organisms. The most common biomass material used for energy are plants such as corn and soy, and the electricity from these organisms can be burned to create heat or converted into electricity. That is, in a direct combustion system, biomass is burned in a combustor or a furnace to generate a heat, hot gas, which is fed into a boiler to generate steam, which is expanded through a steam turbine or a steam engine to produce mechanical or electrical energy. And now we can move to why renewable energy. Why renewable energy means a real alternative, and it is clean, and it is inexhaustible. Renewable energies are safe, and it is available everywhere and not more expensive. So, a real alternative means renewables are not a project for the future or an experiment. They are already a reality, and the production from them and their range will steadily increase. And renewables are clean, so renewables produce energy without releasing greenhouse effect gases, making them an indispensable ally in the fight against climate change. And renewable energy are inexhaustible, and this is why they are known as renewables, right? So fossil fuels such as coal, oil, and gas do not replenish themselves, whereas sun, water, and wind are sources of energy that is always available. And then next one, renewables energy are safe. Renewables energy generation does not pose risk for people or the environment, and which is an advantage with respect to the doubts expressed over the safety of nuclear energy or the concern for pollution associated with fossil fuels. And it is available everywhere. We all know that water, wind, and sun are energy sources that are available all over the world, and that means that the capacity for generating enough and a variety of renewables comes from various supply base for any country, and it is not more expensive. Sun and wind are available without cost, although investment and efficient technological development has to be carried out to make use of them as energy sources. And the next one, why do we need renewable energy? These all are the reasons why do we need renewable energy. We all are know that CO2 increasing global warming, ocean acidification, rising sea level, decreasing ice sheet mass, retreating glaciers, and decreasing Arctic ice. These are all the reasons why do we need renewable energy. And the next one, why not non-renewable? Uh, what's really bad with non-renewable energy sources? That's a question. Why? What's wrong with non-renewable energy? Of course, it is environmental pollution. Burning fossil fuels releases carbon dioxide, which is directly linked to global warming. So, fossil fuels are very damaging to the health of our environment, and this can make the energy generation very expensive. The first reason is that greenhouse gas emission. Of course, greenhouse gas emission and non-renewable energy typically releases carbon dioxide, methane, and other gases into the atmosphere. And similar to the way a greenhouse gas creates a warm atmosphere for plants, the gases create a warming effect across the planet. And the next reason is that air pollution, as fossil fuels and other non-renewable burn, that release pollutants that can make it more difficult to breathe. As more non-renewable energy is burned, the quality of air will continue to decline, forcing more and more people to take other unnecessary measures to protect their health. And the next reason is that water pollution. Water pollution can take many forms. One of these acid rain. Occurs when sulfur and other chemicals permeate the atmosphere. Water pollution can also occur when the water changes temperature as a result of non-renewable resource use. For example, Power plants use water to cool the plant as it operates. When that water is released back into the environment, its cooler temperature can negatively impact wildlife. And warmer water, meanwhile, may decrease the fertility of fish or cause them to change their migration patterns. And the next problem is that land pollution. The extraction process of non-renewable resources can have devastating effects on the land. Surface mining requires a large amount of rock and soil to be dumped in other locations to access the coal bed. So this changes habitats and ecosystems in unexpected ways and can cause animals to relocate. And the next one is the economical reasons. And fossil fuels won't last forever, and renewable provides new jobs, and our country will be less dependent on other for fuels. And reducing energy dependence in the sense as an indigenous resource, the eliminate the need to import the fossil fuels from countries rich in gas and oil. The need to import energy raw materials implies economic and even strategic cost. High dependence on energy from abroad can produce supply uncertainty due to the political and economic problems in supplier countries. So these are the economic implications. And now let's see the India targets. India targets. India has set some targets for renewable energies that India has itself some ambitious targets, um, and we can say that India has its own targets. Why? Because our requirement of energy is increasing day by day, and government has first come up with a target. Every house should have energy, and that's the target. And that there are two types of target normally that we have decided in energy sector. That is short-term goals and long-term goals. So if we consider the short-term goals up to 2022, it was decided that 175 gigawatt renewable energy capacity that we have to generate, and we have to install capacity should have increased up to 175 gigawatt. And I think in 2022, our requirement will increase and population will increase. Considering that our requirement will increase, if our requirement will increasing, we have to find it out that next up to 2030 that they are considering that 420 gigawatt is planned up to 2030. And the government of India has set a very ambitious 2030 target of 520 gigawatt, including large scale hydro. So the reason is that the problem is that we are still lacking our energy resources. So we need to improve our energy sources. And this is the graph showing the progress need for India to meet 175 gigawatt target. And we can see that in 2015 to 2016, it is around 38.01 gigawatt, and in 2018 to 2019, it is around 74.79. And in 2021 to 2022, we have to reach 175 gigawatt and it is show that projected required growth in this side and actual data in this side. It is clear that from this graph. And next one, the current status of renewable energy in India. The pie chart, we can clearly see that from this pie chart, the current status of renewable energy in India. We can see that the most using renewable energy is wind energy, and it is around 62.50 percentage, and the next one is bioenergy 14 percentage, and solar 13, and small hydro 10.50 percentage. And next one is the future of renewables. These are some examples, or these are only the examples, only some examples. Turbulent limitless energy graphing project, ultras, dynamic tidal power, floating solar technology. There are so many innovations are going on the future of renewables, and these are some videos. I will show some videos so that you can understand. Okay. In this video, they excavate a space next to the water and installed prefabricated parts and lower the turbine into the basin. They backfill the excavation and they backfill the excavation and open the river or the canal wall. The turbine starts operating 24 by 7, and the turbine uses a natural whirlpool to generate electricity and making it fish friendly, making it fish friendly. The low pressure in the turbine gets them pass through unharmed, and the generator is the only moving part, reducing failure and maintenance here. And when turning into produce energy 24 by 7 to power up to 60 homes per turbine, and resistant to small debris and sand. Turbulent turbines are designed to empower rural communities all over the world. And the next video, the limitless energy graphing project. Let's have a look.
Know that that's bad. Clear away to get only clean energy, no pollution, unlimited energy. So our first question was, where's the energy? There's only one answer. That's right here. What else underneath that? Unlimited power, unlimited. Where you go, the hotter it gets. Take that energy, up. There a way to bring up just the energy. What it takes is doing the right thing, inventing the right thing. And use copper wire because of wind. So we found this material called graphene. Graphene is a substance that is really made out of graphite, which is like pencil lead. What they discovered was that if they take one molecule layer at a time off graphite, that's called graphene. It's 100 times better conductor than copper. It's lighter than and stronger than steel. Transfers heat really efficiently. 100 degrees here, 100 on the other side instantly. Well, it's computing power. So the heat that you put in gets all the way there. Whether you move that heat, miles, you could bring up unlimited energy down surface.
Okay, the limitless energy graphene project. Graphene is 100 times better conductor than carbon, and it is stronger than steel, lighter than air. It transmits heat very efficiently. And from that video, they said that if they put 100 degree on one side and you will get 100 degree on the other side instantly, and the middle is completely cooler. That's really pretty amazing thing. And we will get unlimited energy from the deep underground to the surface without any pollution. And the next one is ultras. Let's have a look.
High altitude wind turbine on the back. First time, affordable. lot of ways out of necessity, like on the country provides power plants.
In Alpros, it is a high altitude wind turbine, and at higher altitude, they said that it produces twice the energy and less expensive, more flexible, and more efficient. And that's all about that thing. And the next one is dynamic tidal power. Let's take a look.
Volcano is designed to generate electric energy from the condense of tidal water. A long dam that is 30 kilometers perpendicular to the coast interacts with the tidal flow to create a hydraulic dam. A barrier parallel to the coastline at the bottom of the town, giving it a T-shape, amplifies the head on either side of the structure. This hydraulic energy, together with the shape of the tunnel, results in the acceleration of traffic towards the many turbines at the dam. Significant to making such a high level of energy production possible is the use of highly advanced turbines that are designed specifically for this purpose. They work with an extremely low head, are bi-directional, and have a peak output of 5 kilowatts each. A dam 40 kilometers in length can accommodate 2,000 turbines, enough to supply millions of households with sustainable energy.
And in dynamic tidal power, it is designed to generate electric energy from the kinetics of tidal water. And that's all about that thing. And the next one is floating solar technology. Okay, these all are the of renewable energy, and just for some examples only, and there are a lot of innovations are going on, and now let's move to the next slide. How renewable energy can drive a post-COVID recovery? How renewable energy can drive a post-COVID recovery? The COVID-19 pandemic has taken a devastating toll on lives, livelihoods, and economies globally. However, a silver lining to the cloud was that it enabled us to catch glimpses of a better world, that cleaner air, blue skies, and reduced emissions, besides reinforcing the value of public health. And we are now at a pivotal moment as national government design stimulus packages to reboot their economies. We simply cannot afford to return to business as usual and continue to pursue high carbon, unsustainable growth template. Rather, global recovery missions should target a green, equitable, and resilient future. We need to make the right choice and direct investments towards a green and healthy recovery, which is the best insurance against future disasters. And the pandemic has only strengthened the care for accelerating the transition to clean energy. A low carbon growth path can stimulate the economy as well as mitigate the climate risk. And the renewable energy can revitalize the economy by creating green jobs, ensuring energy security, and strengthening resilience. In India, which saw over 100 million job losses during the lockdown period, and around 1.3 million full-time jobs can be created by achieving 160 gigawatt from renewables by 2022. A shift towards renewables can help countries like India save vital funds through a drastic reduction in their import bills. And even if half the generated renewable power is used to replace imported coal, India can save over $90 billion between 2021 and 2031. As a major source of harmful emissions, coal has always been associated with negative consequences, right? So, a recovery driven by renewables can tackle the challenges of air pollution and climate change by being greenhouse gas emissions, thus reducing vulnerability to life-threatening diseases. Last but not least, a renewable driven recovery will contribute to more equitable and inclusive growth by improving access to energy. That's all about our presentation. And okay, and I hope you all can follow me. And renewable energy is crucial for mitigating climate change, and renewable energy provides renewable power supplies and fuel diversification, which enhance energy security, lower risk of fuel spills, and reduce the need for imported fuels. And renewable energy also conserve the nation's natural resources. So that's all today's session. And thank you so much for having me. Thank you.
Thank you, Khadeeja. So we have one question. Uh, what are the tools used to analyze and forecast wind energy in southern part of India amidst COVID? Do you mind spending a couple of minutes to answer the question?
Okay, ഒന്നുകൂടെ റിപ്പീറ്റ് ചെയ്യാവോ?
Sorry.
Once more ഒന്നുകൂടി ക്വസ്റ്റ്യൻ വായിക്കാവോ?
Okay, so the question is, what are the tools used to analyze and forecast wind energy in southern part of India amidst COVID? So the question is about forecasting the wind energy, especially in the southern part of India. Tools used to analyze and forecast the wind energy.
Casting wind energy. I think,
If you need to research and then give a reply, then you can do that after this session.
okay. I will contact that. Please give me his contact number. I will contact after.
Okay. So thank you, Khadeeja, for your presentation. On behalf of IEEE's Kerala chapter, I would like to convey our gratitude for your presentation on renewable energy. I hope it was an informative one. Also, I would like to thank all the participants for registering and participating in this session. Thank you all until the next session.
Okay. Thank you so much. Thank you.